Hey, I'm Michele from messautomation.com, and today we continue our project of building an HMI with C#. Today we will talk about navigation with Prism. In the previous video, we created a single window HMI and connected it to a Siemens S7 PLC. We learned how to use Sharp7 driver to create a PLC service, and we learned how to use MVVM pattern to bind the view to the view model by using WPF. In the previous video, this was the user interface that we built. It was a single window application with a single view, and this was connected to this simple PLC program, and we were refreshing values by reading and writing to the PLC. Today we will do a more complicated application with multiple screens and with multiple regions. In particular, we will add a region on the left of the main window that will contain a menu. Then we will create a region on the bottom that will contain our status bar, and these two regions are common for all the pages. And on the right region, these two pages will swap in this region. So we will use Prism navigation frameworks to display this multiple page, and we will see how to use Prism regions in Prism view model locator. Also, because we have multiple views, we will see how to use the same PLC service from multiple view models, and we will also see how dependency inversion, and in particular using dependency injection containers, will make our life easier when loading services in the view models. So before starting, here are some resources if you want to learn Prism. So let's get started with our application and let's start implementing the navigation. So let's open our simple HMI folder and let's open Visual Studio. So here we have our solution from the previous project, and as you can see we have a single window. So we have to split this window into multiple views, and in particular we have to create a status bar, a settings page and a menu, and keep the main view, that is the one in the middle. So let's create the menu. We just add a user control, a WPF user control, so you have to check that it's a WPF user control, and we can just create a left menu. So let's copy and paste some code, and basically our menu is two buttons, one for the main page and one for settings page. Then we create another user control for the status bar on the bottom, so new user control, and let's call it HMI status bar. And then we have to create a view for the settings, so let's call it settings page. And then we have to create a user control for the main page. Great. So we have the main window here. We have to take the code from the status bar and move it in the HMI status bar. We can just place it here. Let's just remove the grid.row, we don't need it. Then we have to take from main window, take out the entire grid and move them on the main page. Let's just rename. And that's great. And then we need to define VM. And this is our main page. Then we need to create the user interface for the settings page. I will copy and paste some code. So we have to create the view models. So we have to create one view model for every view that we have. So we create HMI status bar view model. We have to create main page view model, left menu view model, and settings page view model. So now that we moved the user interface from main window to main page, we also have to move the code from main window view model to main page view model. So let's copy this code and let's paste on the main page view model. So let's inherit from bindable base using Prism, and we need to change the constructor, and we are done. So let's go back to the main window that now it's just an empty grid, and let's add a reference to Prism. And now let's add some columns and some rows. And let's add our regions that they are just free content controls. So one is for the left menu that will be in row 0 and column 0. Then we have another content control that will host our pages, and this will be on grid.row 0 and grid.column 1. And then we have another content control for the status bar that will be in grid.row 1, so it will be on the bottom, and in grid.column span 2 because we want it on the whole window. Sorry. Okay, so how can we tell to Prism that these are our regions? We can just use prism.regionmanager.region_name, and we can call it left menu region, and again we can call this content region, and the bottom one we can call it status bar region. So it's a good practice when creating the region to add them to a common project. So let's create a new project and let's call it simple hmi.infrastructure, and let's add a new class named regions. And here we can define our strings of regions, so we can use constants all around the program. So let's add a reference to infrastructure, and that's perfect. So now that we created the regions, we can focus on the views and the view model. So let's start from the status bar and let's open the view and the view model. And here we have to complete with the properties. So we have to move from main page, the connection state and the scan time into the HMI status bar view model. And these are our properties. Also these have to derive from bindable base. Then let's create the constructor. Okay. So now we have to refresh the connection state and the scan time from the PLC. So we need somehow the PLC service into here. And the PLC service is local on this view model. So we cannot continue with this approach anymore, but the PLC service needs to be kind of global in our application. So in this case, we use dependency inversion. And we say, I will not create the PLC service inside the view model, but someone has to provide a PLC service to the view model. And this is called dependency inversion. So we will just ask in the constructor to provide a PLC service, and we will associate the PLC service as a private member. And so someone from outside will have to provide the PLC service to us. So we can now move connection state here. And we do the same in the HMI status bar. We will request for a PLC service here. Then we can create a PLC service private variable and assign it. And now we can use the event to refresh our variables. And here we can just copy and paste the refresh method. We need this one, and we need the scan time. So now that we are depending on someone that has to create a S7 PLC service and provide it to the view models, let's see how we can do that with a dependency injection container. And as a dependency injection container in this project, I will use autofuck. To do that, we will go on manage NuGet packages and install autofuck.prism. So here on manage NuGet packages, we search for prism, and we can see that there are several dependency injection containers. We will go with autofuck. And now that it's finished, we have to configure our solution to use this dependency injection container. So we have to create a new class called bootstrapper. And this has to inherit from autofuck bootstrapper. Now to configure our bootstrapper, we need to override two methods. One is create shell, that is responsible to create the main window that will host all our regions. And the second one is initialize shell that will basically show our window. So our bootstrapper is the class that is responsible of initializing our application. This means that app.xaml, it will not be responsible anymore. So we have to configure app.xaml, and we do that by removing the startup URI, and we go on the code behind, and we override on startup. And here we just have to create a bootstrapper and call the run method. So now the startup of the application is completely bypassed from app.xaml, and the bootstrapper is responsible of initialize it, and it will use the dependency container autofuck. To configure the container, we have to override another method called configure container builder. So here we can register our dependencies, so the container will resolve the dependencies for us. In particular, we need the S7 PLC service. So we do builder.register and PLC service. So this tells to the container that when requested for the type S7 PLC service from some classes, he have to provide an instance of S7 PLC service. Now we have to register the regions. So the command is register type for navigation. So this is different for the views, and we have to register main page because we have to give a name to the views. I use usually the name of the class. We have for regions, we have main page, we have left menu, we have status bar, and we have settings page. Again, we have to specify the names. So now that we configured our container, we have to go on main window view model, and here we can use the container to set up our regions. In particular, let's create the constructor, and we ask to the container for a member called iRegionManager. So we need a private variable, and we need to assign it. With region manager, we can assign a particular region to a particular view, and we do that by using region manager dot register view with region. Then it will ask us for the region name, and we have to use this infrastructure dot content region will have to contain a type of main page. So we are assigning to the content region the main page. Then we have to assign to the status bar our status bar, and we have to assign to the menu the left menu, and that's it. Now we can run the application and it's empty. Okay, this is perfectly normal, because if we put a breakpoint on our view model, it will not be loaded. To load the view model, we need to use the view model locator, and the view model locator is something that connects the view to the view model. So Prism has its own built-in view model locator, and for main window, for example, we can just go here and write prism dot view model locator auto-where view model equals true, and we can do that for all our views, and this will wire up the view model to the view automatically. We have just to add prism, and we can add all these lines to all the views, so our view models are automatically loaded. For example, here we were loading the view model by setting the data context. We have to remove this. So now we can go main view model, and Prism will find the view model for us. Let's see it. So it creates the view models, and now it will populate our regions. So now all our regions are populated, so we need to navigate from main to settings by using the command. Let's see how we can do that. So let's go on left menu view model. Here we have to add two commands. One to navigate to the main page, and want to navigate to the settings page. Then we need to add the constructor. And to define these commands, we need a method. So again, we will call from the container the iRegion manager. We have to create again the private property and to assign it. So now we can create a method navigate. And the navigation with Prism works with strings. So we need a URL. And we can use the region manager to navigate. You will need a region name and a source. So we need a regions dot content region, because this is what we navigate, and we will navigate to URL. So now we can define our commands. Navigate to main page equals new delegate command. This needs an action. So here we have an action, and we say navigate to, and we can say main page. And the settings page, we can call them commands. And for the settings page is the same, because we can just do delegate command navigate to settings page. So as you can see, we are using strings to navigate. Now these strings are defined in our bootstrapper, and they have to be the same as the ones that we use for navigation. So while in the main window we can use the type of when we using a register view with regions, when we are using the navigation methods, we have still to provide strings. Now that we created the view model, we have to assign the commands to the view. So let's go to left menu view, let's go to the main button, and let's create command equals binding to navigate to main page command. And again, settings equals command equals binding to navigate to settings command. So now that the commands are assigned, we can run the application, and we see that our view has been created. However, we don't visualize the values from the PLC here because the view model is still not created. So let's close everything. Let's open the settings page and the settings page view model. So settings view model has to inherit from bindable base of Prism. So let's add the properties inlet pump speed and outlet pump speed, and let's add the constructor, and we need the PLC service to read and write our properties. So let's get the service from the container in the constructor, and let's reference service. Again, we have to create a private variable, and we have to assign it. Now when we have to write values, especially when we are editing the settings in the PLC, we cannot poll every time the PLC, but we have to load the settings when we open the page, and when we change them, we have to write the settings after we changed them. So to load the settings when we open the page, we have to implement a new interface that will tell to our view model when it has been navigated. And this interface is iNavigation aware. So we can just add iNavigation aware, and we use Prism, and we implement the interface. On isNavigation target, we have always to return true, and on navigated to, it's the method that will be called when the page is navigated to. So here we can just say that inlet pump speed equals S7 PLC service dot inlet pump speed, and the same for outlet pump speed. And we still have to implement these two properties. So we can just use Visual Studio to create the properties, and we can go on S7 PLC driver, and we can just see that Visual Studio created the properties for us. So we have to refresh these properties every time the timer is called. So we go on the callback of the timer, that is on timer elapsed. Here we have the method refresh values, and I already know that my inlet pump value pump speed is the number 4, and the outlet pump speed is the 6. So I can just... So now that we can read these values, we can connect our view model to the view. Text is in binding with inlet pump speed and text is in binding with outlet. So now that we bound the values from the view model to the view, we need to see how we can write the values. So to write the values, we can just go on our constructor and subscribe to the property changed event. So we can go this on property changed plus equal. So here we listen for the changing of the inlet pump speed variable and the outlet pump speed variable. So we can just say that if a dot property name equals name of inlet pump speed, just call our PLC service dot write, and here we have to create our method, and we say inlet pump speed, and we have to pass also the pump speed. We say comma, and we just generate the method. Then we have to do the same for outlet speed. So now that we generated the method, we have to go on the binding and we have to change the type of binding. So basically, if we leave the binding like this, the event is raised only when the text box loses the focus. For example, let's put a breakpoint here and a breakpoint here, and let's run our application. So if I go on settings page and they change inlet pump speed, our event is not raised. It will be raised when the text box loses the focus. Like in this moment, I click on outlet and it will be raised. But this is not what we want. We want that when we change the values, these values are written in the PLC. So to do this, we will just add some properties on the binding. One is delay, that is our delay. So basically, every time I will input a value, the binding will wait for 1 second before updating the view model. And then we will add this update source trigger equals property changed, so the event will not be raised when the text box loses focus, but it will be raised every time the text is changed. We will add these properties here, and we will add also here. So let's see how it works. We have 2 breakpoints here. Now I go on settings, I will change the number here, and after 1 second you will see the breakpoint will be it, and here we go. So now that we can write on the PLC, let's implement these 2 methods, write speed outlet pump and write speed inlet pump. To write the speed, we have to write a word on the PLC. In this case we have to write the db1.dbw4, and in this case we have to write the db1.dbw6. So we can use our helper method in the same way that we did with the write bit. So we can add our helper method here, and we can write a method write word that will call a dbwrite from #7, then our write word that will take a string into input, and it will pass the string, and then it will call the other write word. Both of them will return the result, so we will know if the write was correct or not. Okay, so let's go to implement our method, and let's start with this. So here we want to use a task to make the write asynchronous. So again, we will use task.run, we will call our write word, we will pass db1.dbw4 as address, and the speed, that's a short. And again, if the write result is non-zero, it means that there was an error and we have to log it. To return a task, we have to change the method return in task. And again, for the outlet pump speed, we have to change dbw6 here, and we have to return a task. So very simple to do this. So we can go back on property changed method. We can await here for our methods to execute them asynchronous, and we can just mark the method as async. So let's execute the application and let's see what happens. So I will just write push connect, and it is connected. But if we see the connection state is still offline, this means that these 3 or 4 screens are disconnected. So this one is connected to the PLC, but it seems that this one it's not. So for example, if we try to write on settings, you will see it gives us an exception because it's not connected. So let's try to see what happened. Let's put a breakpoint on our S7 PLC service on the constructor, and let's put a breakpoint on HMI view model when we need the constructor from the container, and also a breakpoint on main page view model, and a breakpoint on settings page view model. And let's see what happens. So let's run the application. Okay, here we have the S7 PLC service is created from the container. We go on. Then HMI status bar view model needs a PLC service, and the container is creating again another instance. Then the main page view model needs needs also the PLC service. And when I go to settings, another PLC service is created again from the container, and it will be assigned to settings page view model. So basically we have 3 instances of the PLC that they are completely disconnected, and this is completely wrong because we just need 1 instance for the whole application. So how can we instruct the container to do the correct instantiation? We just go on the bootstrapper and we find the register type for our container, and we say to him we want a single instance, and in this case the container will give us a single instance, always the same instance, to the whole application. So let's see what will happen now. We launch the application, someone requests the PLC service, the container creates the PLC service, and so the status bar needs a PLC service, and then also the main page view model. But as you see now, the container didn't create the PLC service and is reusing the old one. And now when we go on settings, the container didn't create the PLC service, but it's using again the old one. So when we connect on main, we go online, and in settings we can set our speed and our outlet pump speed, and we can just start. And we see that even if we change the page, our PLC is acting correctly. We can also change the speed to go a bit faster, let's say 5. And our PLC is going more fast. So another characteristic of Prism navigation is that it doesn't recreate the pages. For example, let's set a breakpoint when we create the settings page and when we create the main page. So we launch the application and we create the main page. Then when we navigate to settings, settings page is created. So the first time that I navigate to settings, the settings page is created. And what happens when we navigate back to the window? It isn't created again. So basically Prism is recycling the pages that they are kept into memory. And again, when we switch to settings, we see this is not recreated. So what if we do have to execute some code when the page is loaded? We have to use iNavigation aware, as I did for settings page, and on navigated to, here is the place that we want to execute that code. The last thing that I want to talk is how this viewModelLocator.AutoWire viewModel works. ViewModelLocator resolves the view and view models based on conventions. Basically, you need to have the views in a folder called views, and you need to have the view models in a folder called view models. So Prism will search for main page in the folder view, a main page view model in the folder view model, and resolve that class. For now, we can keep this convention. It's not a problem. Just remember that that this works only if the views are in the folder views and the view models are in the folder view models. So one of the problems of ViewModelLocator is that we lose completely the support of the designer. So we see that in the previous video, it was really easy to click on an object and say value and create a data binding. And here we had our view model, but here we don't have nothing anymore. So it's basically, it doesn't work anymore. So why have we lost the design data? So we lost the design data because we are not assigning anymore the data context in the XAML, because Prism is assigning the data context by searching with the viewModel locator. So what can we do with this? We can assign a data context by using the design data. And basically we use the d tag data context. This means the design data context. We just say d.design instance, and we can say that the main page view model is this one, and we can say that it is design time creatable true. Okay, so we have an error here because it says basically that we need a parameterless constructor view model defined for this object, but our main page constructor needs a service, and we really need this service. So what can we do to use design time data and use also dependency injection? Okay, I usually create my design time data in a designer class, and I just create, for example, a class design main page view model, and I inherit it from the main page view model. So here we have an error because the main page view model has a constructor that needs one parameter. So let's create our constructor, and we need to call the base constructor, and this is asking for a service. So we have to create a design PLC service. So let's create a design PLC service. Now, how can we create a design PLC service that our PLC service is a class? So we need to create an interface as S7 PLC service called iPLC service. We can just use the refactor of Visual Studio and say extract interface, and we just need to check what we need. We basically need everything here, and just say okay. And this is our interface IS7 PLC service. We don't need to declare S7 PLC service, we just need PLC service. Now, we can just replace all around the program the S7 PLC service with an iPLC service. For example, in the container, we have to register the S7 PLC service as the implemented interface, that it's this one. So this will tell the container that when we request a type of iPLC service, give us S7 PLC service. Then let's go on. So here we have our read-only S7 PLC service. We can just ask for an iPLC service. So we will use the abstract service, and the container will provide us with a real implementation. Again, on main page view model, we will use the interface, and on settings view model, we will use the interface. So now we have design page view model. We can just create a design PLC service. So we will create a different PLC service just for design data, and we implement the iPLC service interface. So let me copy and paste everything. And once we created the design PLC service, we can just go on design main page view model, and on base we can just pass a new design PLC service. And then on main page we have to build. But on main page we can just pass the design main page view model, and instead of VM we can just use design and say. So here we have again the complete support of MVVM, and we can do the same for every view that we have. For example, we can go on the status bar and we can say, yeah, give me a designer of design status bar view model, and we can create the class design HMI status bar view model that will inherit from HMI status bar. We create an empty constructor, and we will call the base constructor, and we will pass the design PLC service. And now we can go on the status bar, and our data is already there, and we have again the support of data binding. As you see, we find everything. So now we saw how to generate design data with Prism even when using viewModel locator. And we saw also how to abstract a PLC service into an interface and use the interface in place of the real service and how everything is still working. So this is quite a powerful concept, and we can write a fake PLC, so we don't need to be connected to the PLC, and the people that doesn't have a Siemens PLC can still try out the application. So let's see how we can do it. Let's create a new class called dummy PLC service. So a class, and let's generate from PLC service. So this is the implementation. There's nothing difficult, but anyway, with this dummy PLC service, I can go on the bootstrapper and say, okay, I don't want anymore to be connected to a Siemens PLC. So let me comment this out, and instead give me a dummy PLC service. Sorry, it has to be public. And give me a dummy PLC service instead of an iPLC service, and I want to close my server and my PLC sim because I don't need anymore the PLC. And let me just start the application and everything should work. And in fact, I can just set my pump speed and everything is working again. So this is the end of the video. As usual, you will find all the links of the source code and the examples on the details of the video, so check them out. Also, if you like the video, leave a like on the video and subscribe to the channel. There will be more videos in the future, and don't forget to visit my website www.mestautomation.com for more articles and also the associated articles of this video. So hope you enjoyed, thanks for watching, and see you at the next video.